We are in chapter 2, chapter 6, and inshallah we'll start discussion. I hope everything is okay. All right. Bismillah ar-Rahman ar-Rahim. Okay, first thing we remember very well. I will go over very quickly over the laws that we have used so far. First law, which is important, and everybody knows this law, is this law. What is C?
Speed of light.
Velocity of light.
What's lambda?
Wavelength.
Okay, and what is nu?
Frequency.
Frequency. That's the first law we took, and it is important. Next, this is the next law, which is this one. What is this?
Frequency.
Frequency, which is nu. And what is E? Stands for what?
Energy.
Energy. And the most important thing in this equation, what is H?
A Planck constant.
It's a constant. It's called Planck's constant. Planck's constant. You must memorize the name. Don't memorize the number. Don't worry about the number. It's available in your periodic table. What I want you to know very well is the name of the scientist. Okay, good. We have this equation, which is important, in which is H times nu. What's H?
Planck's constant.
Nu is frequency. So this is the energy of the light equal to what? What's Ke?
Planck constant.
Kinetic energy. Kinetic energy. And what's W?
Work.
No.
Binding.
Binding energy. Binding. What's the meaning of binding energy?
الارتباط.
Yes. ارتباط. ايش بايش؟
الالكترون بالنيوكليس.
Nucleus with the electron outside. This power or this energy is called W, capital W, which is binding energy. Binding energy أو الارتباط. Okay, I hope we talked about this and hope you know all this equation. Good. We talk about is called
line spectra.
Line.
very
Spectra.
important word, line spectra. What do you mean by line spectra?
Picture.
It's like the picture of hydrogen atom. It's exactly like the picture, and that's why there is a picture, different picture for each element. Each element has its own spectra. Very important slide. Don't know anything. You don't need to know anything about this slide, except if I give you something and I wanted to compare things. Then if I give you a line like this, there is a line here, line here, line here, and line here, then, and this is yellow and this is blue, this is blue, this is blue, and this is yellow or orange maybe. Then which element I'm talking about here at the top?
Lithium.
Lithium, because the picture is the same. So this is the pictures, and if I give you something to compare, you can easily compare with it. Okay, good. Next.
Doctor,
Yes.
should I know the picture or all of
Oh,
the element?
picture. Just compare to it. Yes, you need to compare things to it. Okay, next, we have then Yes, this equation, very important equation. What's the name of this equation?
Line spectrum of hydrogen.
No, the name of the equation. It is related to the line spectrum of hydrogen, but what's the name of this equation?
Energy.
Bohr theory.
Not, yes, Bohr equation or Bohr theory, related to Bohr theory again, but it is Bohr equation. All right? And what does it say? It gives you the energy between these spectral lines, which are these lines. So the difference in energy between these lines, that's what the equation tell you. The difference in energy in this line, very important. Of course, delta E is the difference between any two lines. If you take between 2 and 4, for example, then this between 2 and 4, the green line here represent the energy difference between 2 and 4. So we want to know what's the value for this green line. If you take it from 5 to 2, then which line that you're going to represent? From 5 to 2.
Blue.
What?
The blue line.
The blue line.
The blue line, exactly, the blue line. All right, and so on and so forth. Now, I want you to understand, what will be the energy going from 2 to 4?
The green.
The green, but what's the difference?
2.
Yeah, but what will be the difference between the
negative energy.
Exactly. From 4 to 2 is negative minus x, which is the green light, the value of green light. And from 2 to 4, this is from 4 to 2, it will be exothermic, and the value will be, if it's x, the green line, the green line value is x, then it will be negative x. But if you go from 2 to 4, what will be the value? It will be exactly x again, but what's the difference?
Positive.
Positive. So this is endothermic, and this is from 4 to 4 is
Exothermic.
Is this clear?
So, doctor, if electron want to go upper, he needs energy, more energy.
It needs energy to go up, yes. Go. All right, yes, good. This is the line. Again, we know delta E is energy. And why we have it delta? Because the difference between 2 and 4, or any numbers. I mean, if we want to take it up between any numbers. Okay, what's H?
Black constant.
What's new?
Frequency.
Frequency. What is N? In final and initial, what are these numbers? We call them what?
Principal quantum number.
Principal quantum number. You have to memorize the name very well. Principal quantum number. And what do we mean by quantum number? It's just simply what? 1, 2, 3, 4, 5, and so on. Clear? Okay. What is this constant? Don't memorize the number. What's this constant? 2.8.
Right.
Of this constant.
Rydberg.
Yes, you must memorize the name. Don't memorize the value. But Rydberg, you have to memorize the name. Rydberg constant, and we're represented by RH. RH. And it's given to you in joule if you want to calculate energy. If you want it in meter to calculate wavelength. Usually we go with joule, and then if you want to calculate RH, it is RH divided by HC, which we know that energy equal to H nu, right? Or equal to what? HC over lambda. HC over lambda. So if you want to calculate 1 over lambda, the energy, actually we divide by HC, this value. I hope this is also clear. Good. What's the equation of de Broglie? Very important. You must memorize the name and the equation. What's the de Broglie equation?
Lambda equal H over mu.
Lambda equal what?
H over mu.
Fantastic. Mu. Excellent. You must memorize this equation in which you know everything. What's lambda?
Lambda the distance.
Wavelength. What's H?
Planck
Constant. What's M?
Mass.
What's U?
The particle.
Velocity, speed of the particle. What is this equation can do? It can change what? Change mass, what?
Light.
To waves, light, mass to wave, light. Light is better. Light. Okay, in which we have waves. All right, or change light to what? To mass. Of course, what's the light, by the way, light particles, what is it called? Light
Photon.
particles, yes. It is called photons. Photons. Photons, that is, when you change the light into mass, you will get photons from the waves. Photons, very good. We also have another equation, which is not, and you don't have to memorize because it's very easy. It's 2 by r equal to n lambda. 2 by r equal to n lambda. What's 2 by r?
Circumference of circle.
Circumference. بالعربي.
محيط.
محيط.
محيط. المحيط. And what is n?
Principal quantum number.
Number of waves.
Number, excellent. And what is lambda? Wavelength. And principal quantum number is 1, 2, 3, 4, 5. Good. We also talked about this. Then we have another, what's the word? Diffraction of electron. What's the meaning of diffraction?
تفكك.
No, diffraction, electrons give light. Electrons give light. See, this is the diffraction of electrons, and it gives light because of diffraction. That's another way to prove also de Broglie equation. Light can come from mass. We change mass into waves, and this is by diffraction. Good. Okay, uncertainty principle. Do you know what's the uncertainty principle? What's the name of the scientist first?
Heisenberg.
Heisenberg. What's the uncertainty principle? You must memorize. Delta
X multiplied by delta P
P greater than
greater
2
or equal H over 4B.
or by. What's X?
Position.
Position, exactly. And what's P?
Momentum.
Momentum, which is equal to what?
Ether.
What's momentum? Mass times
Velocity.
that change in velocity, because it is a change, so it's change in velocity, okay? And of course, everybody knows what's H. Yeah. Okay, good. Next, Schrödinger equation. What's Schrödinger equation? Yes?
BSI.
PSI, which is called psi. It's written PSI, but you pronounce it psi. Okay. And what should I do? What's psi? It is this symbol. Should draw it better. It is this symbol. Okay. Okay.
This represents the electron.
Exactly. That's the whole thing. All what I want you to know about Schrödinger equation is this thing, psi. That's it. Okay. But tell me, what is psi? What is
Wave
psi?
function.
Wave function to do what?
Represent electron or
To represent the electron. That's it. Clear? It's a wave function. You don't know what, you don't have to know what's this wave function or that. It's just a mathematical equation to represent the electron. So if I tell you what's the electron, you can give me equation to represent that electron. That's it. Is this clear? Okay. What is more important than psi is what? Psi square. What's psi square?
The probability.
Probability. Probability of finding the what? What? The electron. Probability. ايش معنى probability بالعربي؟
احتمالية.
احتمالية.
احتمالية وجود الإلكترون. So this wave function, tell us what's the, it can make calculation to represent the electron. And this psi square tell you where to find the electron exactly. And by doing this, as I said, what's the name of this equation?
Heisenberg.
Heisenberg. Give me the full name. Heisenberg uncertainty principle. Uncertainty principle. Okay, and this is another way of writing Heisenberg uncertainty. And then what is, yes, what is this letter?
psi.
Psi. Psi. You have to memorize. This is the way you write it, but you say psi. Again, what does the psi represent?
electron.
Represent the electron. It is representing the electron. Representing the electron. So if I say give me equation to represent the electron, you say psi only. And what's more important, what? Psi square. Psi square. What does it do? Probability of finding probability of finding the electron. All right, good. All right, and with this we start looking at, see, now with this picture we see the electrons as this is the electron as light. So how many electrons do we have here in this whole picture? How many electrons maybe we have?
We don't know.
Maybe 1 or 2 maximum. 1 or 2, and we don't know what's the difference between if it's 1 or 2. What's the
color.
No, it's not the color, but intensity. What does intensity means?
شدة.
الحدة.
brightness.
Brightness, yes. So if we have 1 electron or 2 electrons, which one will be more intense?
2 electrons.
2 electrons.
Is this clear? That's what I want you to know. Good. Now we go to what's called atomic orbital. By solving the wave function, which is psi, we came up with many solutions by solving this equation. What do I mean by this? If I tell you x squared equal to 9, then what's x?
3
Plus minus 3.
Yes,
plus minus
two solutions, plus 3, or x could be, or x equal to what? Minus 3, right? Is this clear? So by solving the equation, you will get many answers like this. That's exactly what happened with Schrödinger. They start solving the equation when n equal to 1, 2, 3. Okay, first, before we go, I want you to look at this slide and sit down today, memorize everything in it. What's the name of this n? It's called what? We already talked about this many times. What's the name?
Principal quantum number.
Principal quantum number. Principal quantum number. You must memorize the name and the letter. And it's called principal quantum number. We have 4 quantum numbers. I want you to memorize extremely well. Extremely well. Okay, first one is, we know, we talked about it a lot, which is called principal quantum number. Second one is called angular momentum quantum number. You must memorize the name. Angular momentum quantum number. Angular momentum quantum number. And we represent it by the letter L. L. Angular momentum quantum number. The third quantum number that I want you to memorize is called magnetic quantum number, ML. M sub L, so we draw it M sub L like this. All right, and the last quantum number is called electron spin quantum number. We represent by M with small s. I want you now read all these 4. Now read it yourself. I mean, principal quantum number N, angular momentum quantum number L, magnetic quantum number ML, electron spin quantum number MS. I want you to sit down today and memorize these things. It's very easy to memorize. It will take you less than 1 minute, maybe 20 seconds or whatever to memorize it, but I want you really to memorize it. All these are numbers to represent the solution for psi equation. So we are going to solve psi equation, and these are all numbers to represent the solution. So when we talk about n equal to something, we'll always have the value 1, 2, 3, 4, 5, 6, and so on. So always, what is n?
Principal quantum number.
Principal quantum number. Principal quantum number. What is the value for n? What are the values?
Integer numbers.
Integer starting from 1, 2, 3, 4, and you can go to any number. Usually we don't pass 8 or 9, but even you can go or more than that, but usually 6, 7, 8, and maybe 9, and then we'll stop there. Approximately. Maybe there is 10, but we will not reach to this value. Clear? Any question? Good. Now, when we go to L, what's the name of L?
Angular momentum.
Angular momentum, quantum number. You must memorize the two words, angular momentum to quantum number. So there, I will give you two questions. You have to memorize these two questions very well. First question is how many L N N. And the other question, what is the value in of what's the value of L? Okay, so if I ask you how many L in L, you should take what is the value of N and do it. The answer is N. Same number. Okay, what are the values for L? You should start, what are the value of L? You should start with 0 and go all the way to N minus 1. Take these notes, very important. Okay, now if N is equal to 5, N is equal to 5, then how many L are there in the solution?
5.
Exactly, 5. What are the solution? What are the values?
From 0 to 4.
4.
0, 1, 2, 3, and 4. So how many solutions? One more time. How many? Count them. 5 solutions.
5.
So there are 5 solutions. That's why we said N, because it's 1, 2, 3, 4, 5. And what are the values? It is from 0 to 4 to N minus 1. Okay. If N is equal to 7, how many L solutions?
7.
7. What are the values?
From 0 to 6.
Write them. 0, 1, 2, 3, 4, 5, and 6. Now count them. How many? How many solutions?
7.
7 solutions. Do you understand now? Okay, is this clear?
Yes.
Okay, very good. So the 0, 1, 2, 3, 4, 5 are the values. This is the number. But when I ask you 7, this means how many? Just I am asking you how many solutions are there. But the solutions is exactly like saying if x squared equal to 9, how many solutions do we have?
2 solution.
2 solutions, exactly. 2 solutions. What are the solutions?
3 and minus.
Minus 3 and plus 3. And that's 2 solutions. Is this clear? Good. I hope so. Now, we have also another name for the L. So L always take the values from what? 0, 1, 2, 3, 4, and to n minus 1. Right? Clear?
Yes.
We have another name for these values. Instead of calling them 0, 1, 2, 3, 4, we're going to call this one S. We're going to call the one P. We're going to call the one D. 2 is D, and 3 is F. And if you want 4, we'll never reach to this, but we can have G. If you want 5, it's called H, and so on. But not important. So this is another way of saying the numbers. Instead of saying 0, 1, 2, 3, we're going to call them S, P, D, F. So if n is equal to 3, that's a good question. N equal to 3, how many solutions do we have?
3 solution.
3 solutions. Good. What are these solutions?
0, 1 و 2.
0, 1, and 2. Can you, instead of telling me 0, 1, 2, can you give me another name?
SP.
S, P, and D. It's the same thing. So if somebody said the solutions are only, the solution says S, P, and D. Is this correct?
Yes.
Yes, it is correct. Or 0, 1, and 2. If I have S orbital or P orbital, what's the value for L for this orbital? What's the value for L?
3.
No.
1.
Yes. Why are you saying 1?
Because B represents 1.
Exactly. If I have F solution for L, what's the value for L?
4.
Yes.
3.
3. Don't forget, S is 0. Keep this in mind. P is 1. D is 2. F is 3 always. Is this clear? I hope so. Good. Done with L. Are you sure you know what you're talking about now? About L. Good. Now, I'm going to take this out, all of it. So we have, well, let's do it here. Okay. Now, we're going to when we know L, if you know L, which we know that L is the second, what's L, by the way? What's L? Yes?
Angular.
Angular momentum quantum number. Okay, what are the values for, first, how many L do we have in any N?
N.
The same for one.
Same better, N. So as I said, how many? You should say just N. Okay, what are the values? From 0 to N minus 1. Clear? Now, if we have L, then I want to do ML. ML, again, you have to answer two questions. If I ask you, how many ML in L, and the second question is, what is the value of ML? If I ask you how many ML in L, you should tell me it's 2L plus 2L plus 1. Okay? And if I ask you what is the value, you should tell me I start from minus L to minus L plus 1 to 0 to L last. No. Okay, I'll give you an example. If L is equal to 0, L is equal to 0, okay, then how many ml do we have? How many ml? How many?
One.
One. One. What's the value?
0.
0. Yes, if it's from minus L to plus L, which is 0 to 0. You have no choice. Good. Now, take this out. I'll give you another example. If L equal to 1, how many ml do we have?
3.
3 ml. What are the values for ml?
Minus 1. 0.
Minus 1,
0.
0, and 1. Is this clear?
Doctor,
Just a second. What's the other name for L equal to 1? What's the other name instead of 1?
S or P.
P. P. Good. Don't forget this. Okay. Let's take this out and we'll talk about this in a while.
Doctor, I didn't understand the value of ML.
I'll go back one more time. ML, we want to know how many ML in L. The first question is how many ML? You should answer by whatever give you the value of L, you should always answer 2L plus 1. So if the value of L is 3, then how many ML we have?
7.
7. Yes, you should say 7. Exactly. Why? Because 2 times 3 plus 1 equal to 7. That's how many. How many? Now, next, what is the value? You should start from minus 7. And what's after that? Sorry. We start with minus L. You start with what?
Minus 7, minus 6.
No, minus 3. You start from minus L. Minus 3. What's next?
Minus 2.
Minus 2.
Minus 1.
0, 1, 2, and 3. Count them.
7.
1, 2, 3, 4, 5, 6, 7. That's how many solutions we have. Is this clear? I hope so. Now, if L is D, L is D, Then how many ml do we have? How many?
2.
No, how many ml?
5.
Yes, 5. 5. Why are you saying 5? It's absolutely right. 5. Why?
Because
D equal
is
to multiply by 2 plus 1.
2.
D is 2. D is 2. So L is 2. And ml, that's how many? You should say minus 5. What are the values?
Minus 2, minus 1.
Minus 2.
0, 1, 2.
Minus 1, 0, 1, and 2. Count them. How many solutions now? 1, 2, 3, 4, and 5 solutions, exactly like this. Is this clear? And that's how we do the principal quantum number, the angular momentum quantum number, and the magnetic quantum number. And you should be able to answer all of these things. Okay? Now, we call each ml, we call it, another name for it, for ml, we call it orbital. And I want to now we call ml, another name for it, orbital. Orbital. You must memorize the orbital. Okay. Now, and each orbital have a value of these things. We usually represent these lines by, these numbers by line. So if we L equal to 2, now I want to go. I hope this is clear. You memorize this already. So let's do it one more time. If L is equal to D, again one more time, then how many solutions do we have?
5.
5 solutions. 5. Okay, we do them by lines. 1, 2, 3, 4, 5. What do we call each line? What do we call each line?
Solution.
Orbital. Orbital. And what are the values? What are the values now? Start.
minus 2,
Minus 2,
minus
minus 1, 0, 1, and 2. And for L equal to 2 or L equal to D. Clear? Okay, very good. Let's do it for easier. I'll take this out now. Here. When L equal to P, then how many solutions do we have?
3.
Yes. What are the solutions? How do you do it?
Minus 1,
1.
0, 1.
Minus 1, 0, and 1. Clear? Okay. When L is equal to S, then how many solutions?
1.
1.
How many solutions? 1. Exactly.
6.
What's the value for the solution?
Just 0.
Yes, 0. When L equal to F, how many solutions do we have?
11.
No.
7.
9.
No.
7.
7.
7. Don't forget 12 plus 1. 12 plus 1. The solutions. F is what?
3,
So
Three.
how many solutions we have?
7.
7. 1, 2, 3, 4, 5, 6, 7. What do you call each solution? What do you call these lines?
Orbital.
Orbital.
Orbital. What are the values?
But doctor,
Yes.
why we
-3,
get to
-2,
minus like -1, -2? From where this minus come?
This is from the solution of psi. You don't have to worry about how we did the solution. You remember this equation psi? When you solve it, you will get these numbers. But we are not going to discuss these things. Okay? So what are the values?
-3, minus
-3,
I want to tell you
0,
one.
1, 2, 3.
I want to tell you one thing. How do I write these values? It's not important. I don't have to write it always like this. I can make it +1, 0, and -1. It's okay. This is a good solution. I can write it also instead of this because it's not important. These are the solutions, but if I want to write, what are the solutions? When p is equal to 3, what are the solutions? What is it? -1, 0, and
1.
1. The order is not important. I can write it. Is this okay?
Yes.
Yes, it is okay. I want you to know this. Okay? Very good. Can I write it another way? Can I write it, for example, can I write this?
Yes.
I can write this. But can I write this? Zero, 1, and 0. Can I write this? Huh? No, wrong. Why?
Because you replace -1 by 0.
I cannot have it in two places. So if this is 0, the other one must not be 0. So one of them is wrong. This one is maybe erase and change one of them, anyone, to -1. Same thing with if. If we have if, how many solutions do we have if we have if?
7.
7. What are these solutions?
-3 and -2.
As I said, the order is not important, but yes, -3, maybe I will -2 here, and then what else?
-1, 0,
-1, 0, what
1,
else?
2, 3.
1, 2, and 3. Any order, but these are the solution. Is this clear? I hope this is clear. Good. The last quantum number that we're going to talk about today is ms. See how much time I spend in this slide. I want you to spend a lot of time today to just do what I did here. Now, you don't have to memorize everything. You need to know what are the values. The ms is different than the others. The ms is called, what's the name of ms?
Electron spin quantum number.
Electron spin quantum number. You must memorize the name. ms. What's the name again? Electron spin quantum number. And it has only two solutions. Only two solutions. It is either plus half or minus half. Only two solutions. Only for ms. It's not related to all the other 4 quantum numbers. And we represent the ms by an arrow. So we have arrow going up and arrow going down. The arrow going up will always give it the value plus half or minus half. It doesn't matter because they're same energy. But the other one will be then minus half. Again, I repeat one more time. I will take everything here. The fourth quantum number is called spin quantum number. Spin quantum number or electron spin quantum number. Spin quantum number we represent by ms. How many solutions do we have?
Only 2.
Only two.
Two solutions. What are these solutions?
Half minus half.
Minus half plus half.
Half and
Minus half.
minus half. How do you represent it?
By row.
Arrow going up means half, and arrow going to down means minus half. So what's the value for ms in here? For ms, what's the value for ms of this electron?
Doctor, how do we know if it's plus?
It's plus half or minus half, it doesn't matter. If you tell me minus half is correct, but let's assume that the up is always plus half. Let's assume that. Okay?
Okay.
All right?
Doctor,
Then what will be the value for ms for this electron?
Minus half.
Must
Plus
be.
half.
Can I say plus half?
No.
Say plus half. I cannot. Why? Because I already decided that going up is plus half. But I can decide from the beginning, so no, I'm not going to put this as plus half. I'll put the one which is up as plus half. Okay, if I say that the one is going up is minus half, it's only two solutions and you can choose. If this one is minus half, then what will be the value for ms for this electron?
Plus half.
What will be the value for this electron? Can I say it's okay to have plus half?
No, minus half.
It must be minus half. Similar to the one which, because I already decided that this is minus half, so this is also minus half. Is this clear? With this, we start building the electronic structure. As I said, don't memorize. I mean, we already talked about this. Memorize this table very well. All what you need to know that 0 is what? 0 is S, and 1 is P, and D is 2, and F is 3. I hope you know this. Good. With this, we start building the electronic structure. And the way we are building the electronic structure is like this. Okay, with psi square, we start knowing, the shape of the orbital. We found that the shape of the s orbital is like a ball. It's not a circle. This is the s orbital. S orbital. The shape is what? Ball. What do I mean ball? Kora. It's not circle like we used to know. You remember Bohr put it as a circle. Now the electron is a ball. And where is the electron in this ball?
Around it?
No. It's exactly light inside it. It's light inside this ball. Is this clear? Is this clear?
In orbitals?
In any orbital. if I have an s orbital, this is the s orbital, it's like a ball. Ball, don't forget, it's Cora. All right, where is the electron? Is it here, or here, or here, or where? No, it's all inside the wall. It's exactly like putting light here. It's light. If you have light inside this ball, where is the light?
Everywhere.
All over the ball, exactly. So the electron is light inside this ball, and this is the shape of the s electron. If you want to take the probability of finding the electron, these are the probability. This scheme shows that we have the probability of finding the electron, and you can see the electron is the blue things inside. This is part of the ball now. Part of the ball, and the electron is like the blue thing inside, and you can see there are white things, means the electron is not there, the light is not there, and that's what we call this. If you remember, we call these nodes. Nodes where the light value is 0. So we have nodes here, nodes. And everywhere these are nodes, the value is 0. Is this clear? And this is how we see the s orbital. The p orbitals are like this. All right, the shape, we call it dumbbell shape. Maybe it is dumbbell with B, so it's not. I think it's dumbbell or dumbbell shape. Okay, this is the shape of the p orbital. Where is the electron in the p orbital? Where is this electron?
Inside it.
It's
The
the,
same inside.
it's the blue thing. Can you see the blue color? The blue color is one electron or two electrons. It could be one ball or all the blue color is the electron. So the electron is light, and this light is available here, the blue color, and then now I make it red, and here. It's one electron, but the light of it is available here and here. It's one electron. If I put two electrons, it will be more intense. This is the shape of p orbital. And this is the shape of the d orbitals. The d orbital, and the electron you can consider like the gray color, the gray color inside. So the electron is available or in here. One electron is available here, 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 and here, because it is taking the whole color. With this solution, we start drawing the electronic structure of the orbital. With hydrogen, this is for hydrogen atom only, hydrogen atom. Okay, what happened? What is, this is n equal to 1. So what's the value of n? That's the value of n.
1.
1.
Hello?
1, doctor.
1.
Yes, why understand? The value of n is 1. Very good. We write it usually here. Good. How many L do we have in n? How many L?
The same.
1.
How many L?
1.
1
1.
and 2 and 3
Come
and
on.
4.
L is
For
n
what
number,
is
doctor.
for n?
For L, we say how
N number.
3.
0.
what are the values?
equal n. So it's
Doctor,
1.
it's the same
The
for
value n minus
Yes. How many,
minus
we can say, how many n and l is the same number? No. How many n? N is equal to 1. How many L?
1.
the same one.
Yes. What are the values?
0.
0.
From 0 to minus 1. To n minus 1. And that's why it's only 0. Clear? Good. So if I want to write the value of L for this box, what's the value of L? It is 0. What's the other name for it? Instead of 0, what's the other name? S. And that's why I write 1S here. 1S here. Okay? Good. Now, what is the value of MS here? Again, if I want ML, 2 questions. How many?
3.
How many? No, the answer is always 2L plus 1. And what are the values?
3.
Minus 1, 0, and 1.
I want it in letters. Minus L to 0 to plus L. You have to know these 2 rules very well. Okay, good. So N is equal to 1. How many ml?
3.
N equal to 1. How many? The answer is what?
Doctor, 1.
0.
1. No, not 0. 1. 1.
Doctor,
What
you
is
said
the
you
value?
want MR.
What's the value?
0.
0.
0. Good. Good. All right. Okay. Now, how many ml do we have?
3.
3.
No. If this is the value of L, if the value of L is 0, then how many? The value of 0. 2L plus 1 is 1. So there is only 1. What's the value? What's the value?
0.
0.
From minus 0 to plus 0, which is 0. Exactly. So this is the solution. Good. Let's go to n equal to 2. How many L are there?
2.
How many? Exactly 2. What are the values?
0, 1.
0 and 1.
And 1. Exactly. What's the other name instead of 0 and 1? How can we put another name? What's the other name?
S and B.
SP.
And P. Now we go to ML. If L is equal to 0, like this one, how many ML do we have?
1.
Plus 5.
1. ML is 1. What is the value?
0.
0. Exactly. When L equal to 1, how many ML do we have?
3.
3. Look at them. 3. And what are the values?
Minus 1 and 0.
Minus 1, 0, and 1. Is this clear? Very good. Next, and n is equal to 3. How many ml do we have?
7.
How many?
7.
N equal to 3. How many L?
3 L.
3.
3.
What
3 L
value
and
of
7.
L? Value of L?
0, 1, 2.
0, 1, and 2 only. Okay. Now we're done with L. How many ml do we have in 0?
1.
Only one, and that's it. How many ml do we have in one?
3
3. What are the values?
-1 0 1
Okay. How many do we have in D?
7.
No.
5.
12 plus 1. 5.
5. 5.
What are the values? -2,
Minus
-1, 0, 1, and 2. Okay, when n equal to 4, how many ml?
4.
4 solution. What are the solutions? 0, 1,
1, 3.
2, and 3. Can we give another name? Instead of 0, what should we say?
S.
What's what the B or the 1?
P.
And the 2?
D.
And the 3?
F.
Very good. What is the, how, if is 0, how many ml do we have? How many?
1.
1. What's the value?
0.
0
It's 1 and the value is 0. How many, and P, how many do you have? How many solution? When P is 3 solution, what are the values?
-1, 0, and 1.
0 and 1. When L is 2 or D, how many solutions?
5.
What are the values?
-2 -1 0
0, 1, and 2. When L is F, then how many solutions do we have?
7.
7. 7. 2L plus 1, 7. What are the values?
-3, -2, -1, 0, and 1 or 2, 3.
We have 7 solutions. I hope this is clear. All right. And now when these orbitals, these are everything is called here orbital. So this is S orbital, this is P orbital, this is P orbital, this is D orbitals, this is F orbital, and so on and so forth. Each orbital can take maximum 2 electrons. Maximum 2 electrons any orbital can take. Is this clear? Now, these orbitals are now for hydrogen atom only, and you can see all the energy of these orbitals are the same. When n equal to 2, these are the same energy. N equal to 3, the same energy. But when you go to bigger atoms, then things become different, and the energy will become different, and things will be separated like this. This is for atoms other than hydrogen. Other than hydrogen, you will find that S will come below 1s, after it 2s, and then 2p, and after 2p comes 3s, and then 3p, and then 4s, and then actually
3D.
4s comes before 3D, and then after that comes 3D, and then 4p, and so on and so forth. And this is the way, and each one of these boxes is called what? What's the name of each box?
Orbital.
Orbital. Maximum number of electrons that I can put in any orbital.
2 electrons. Only 2 electrons.
2 electrons. 2 electrons. 2 electrons. And these two electrons must be spinning in different direction. So 1 electron is here, the other electron must be like this in the same orbital. If they are in the same orbital, they must be spinning like this. Okay? Each one is called electron. Now, the maximum, the electron that you can, what's the maximum number of electron you can put in any orbital?
Only 2.
What's the maximum? The answer is what?
2.
2. And this is called Pauli exclusion. I want you to memorize the name. Pauli exclusion principle. Pauli exclusion principle. This is the name, Pauli exclusion principle. Remember it. What's Pauli exclusion principle? The maximum number of electrons you can put in any orbital is
2.
2.
and they must be
opposite sides of each other.
opposite. What letter we use for this? They must have different what? M, S, fourth quantum number, spin quantum number. You remember spin quantum number? Last spin quantum number. They must be spin in different directions. This is called Pauli exclusion principle. You must memorize Pauli exclusion principle. It says that the maximum that you can put is 2 electrons and they must be spinning in different directions. Good. That's called what? Pauli exclusion principle. Memorize the name, very important. Next, another rule I will give you. Don't forget this rule. Okay, the other rule is called Hans rule. Hans rule says that if you have electrons in the same, this is what am I drawing now? What's this? What am I drawing?
Orbit.
Which orbital?
3.
Only 3 boxes. So which orbital is this?
P.
P. Must be. Okay. When you want to put electrons in P, according to Hans' rule, you should have the maximum spin. What do I mean? If you put the first electron, you should put it spinning, for example, up. Then when you want to put the second electron, you must also have it spinning up. And the third electron, how are you going to put it?
Up.
All spinning up. We call this maximum spin. Okay? Then if you have 4, then what are you going to do? You can now put it, but how should I put it?
Down in the first order.
I should put it spinning down, according to which law?
And
No, if it's spinning down, there's a Pauli exclusion principle. The maximum that you can put in any orbital is 2 electrons, and they must be in different position. Different spin. Clear? So we must know now Hans rule and Pauli exclusion principle. Now I'll give you, this is Ram. Again, I want you to sit down today and memorize it. It's very easy. When n equal to 1, there is only one S. You cannot have more than this. When n equal to 2, there is 2S, 2P, 2 solutions. When n equal to 3, there's 3 solutions. And when n equal to 4, 4 solutions. And when n equal to 5, 5 solutions, we did not draw it. there is actually another box here, but we are not going to reach to it, and that's why we did not draw it. When n equal to 6, then how many boxes do you have?
3.
3 more, but I did not draw them. Why the author did not draw them? Because we are not going to reach. Is this clear? And when n equal to 7, how many solutions do you have?
7.
7, 1, 2, 3, 4, 5, 6, and 7. But since these we're not going to reach, we're not going to put them. Or you can keep them. And then I wanted to know how to draw the arrows like this. Start from the top, going down, top, going down, top, going down. And that's how the arrangement of the orbitals. So if you want to write this now, I will write it writing 1s, and then what comes after 1s? 2s, and then 2p, and then
3s.
3s, and then
3b.
3p, and then
4s.
4s, and then
1d.
3D.
3d. 3d. What's after 3d?
4P.
4p, and then
5S.
5s, and then
4d.
4d, and then
5P.
5p, and then
6S.
6s, and then
4F.
4f, and then
5D.
and then
6P.
and then
7S.
7s. I want you to memorize how to draw this box, to make this box, and then you'll be able to write all of these things. This is called off-bow principle. Off-bow principle. Okay, and with this, we will stop here. Let me take attendance as usual before we go. Discard. Okay, and then let's go to this one. And this is okay. Okay. Now the attendance is available for you. And if you go to yes, if you go to
Doctor, can you send the link?
yeah, I will send the link right now. Oh, you want to send the link?
It is in more.
It is in more, but copy and then let's send it one more time. Okay. I send it already now. Refresh your page and then go and make the attendance. Accept responses.
Doctor, it's still closed.
Now it's open. Refresh your page and it will be open. Go ahead. And you can leave.
Doctor?
You enter, you can leave.
Doctor?
نعم.
What about the average of the midterm?
والله لسه ما طلعت نتائج الى الان. توني شيكت قبل المحاضره ولسه ما طلعت نتائج.
متى ممكن تطلع؟
اليوم ان شاء الله. definitely ان شاء الله. ولكن maybe late today.
يعطيك العافيه.
I will send it to you on WhatsApp or whatever. What's the average?
اوكي يعطيك العافيه.
دكتور الآن والدرجات بعد كلها للطلاب؟
نعم.
هل تنزل يعني الافرج ولا لكل طالب درجته بعد؟
كل طالب درجته ان شاء الله، بس اول برسل لكم الافرج وبعدين انا بنزل لكم العلامات لكل طالب طبعا. حتى اليوم ان شاء الله.
يا دكتور في كويز قريب اسبوع ما في؟
خلاص في كويز الاسبوع هذا في شابتر 6. او اي ويل اناونس
الخميس
باي واتساب. نعم.
السبت خلي الخميس.
السبت افضل.
خليه الخميس ولا السبت يا شباب؟
السبت.
انا فضل
السبت دكتور.
السبت افضل.
السبت ان شاء الله بنخليه اذا السبت مساء الساعه 9:30 نفس الشيء اخر شيء.
تمام.
اوكي يلا خلاص بسكر الموقع الآن، انتهى التحضير.
دكتور في أي شابتر